Okay, so yeah, let's look at some potential bearings. So you're pretty good on starting at the center and then recognizing we have to start either facing north or facing south. Just imagine facing that way. And then if I got to go to the west, how many degrees? In this case, start at north, we turn 70 degrees to the west, so that's why we use the notation north 70 degrees west. Okay, let's say we're starting at a problem here. And I see problems like this with, we always like going nautical, boats. There's a boat going, say, 20 degrees east of north. Now, do you understand when I say 20 degrees east of north?
Yes.
It means the same as what?
20 degrees from the north to eastern direction.
Yeah, if you start in the north facing that way, go 20 degrees. Okay, good. So we'll draw that down like this. Let's say it's a point right here, and you know this is north, this is east, and so on. And you can actually imagine putting those little compass points at every single point you change direction. I think that's really helpful. Okay, let's say this is 5 miles. So let's say we're going to start at some point. We go north 20 degrees east for 5 miles. I think I have the idea of what sort of problems you wanted to go over. Okay, and now let's say we turn 60 degrees to the right. Okay, and we go for 6 miles. So it's one of those problems where we give you stuff in a paragraph, and then it's really up to you to do a halfway decent job drawing the thing, okay? So a couple questions. First off, what's your bearing now going to be? If you're starting here and we're turning 60 degrees to the right, you can imagine that you were originally going in that direction, which was north 20 east.
Does that make so like that? Oh, we pivot to here.
Well, we're going to pivot, but only 60 degrees.
Yeah.
90 degrees would be a perpendicular thing. 60 degrees is less than, right? So if you're starting here,
maybe. What, to the right?
well, you kind of have the right idea, but if we're going to the right, we're facing this direction, right?
Yeah.
And now we're going to turn that way 60 degrees. So imagine making like a 60-degree angle.
Okay.
Would it go as far down as east, as due east?
No.
Right, very good, because if this is 20 degrees, what is this?
70.
70. So if we're only going 60, it's a little bit less, right? Okay, so what would you say, keep in mind these crosshairs, I'll call them these coordinate, compass points. What could we call that? What would the bearing of that be?
Would that be?
Well, is it going to start with south?
No, it'd be still be north.
So it's still going to be north. It's going to be north.
Something east.
Very good. North something east, and then fill in the blank, right? Well, we want to find this angle from north, from this north compass point. So think about what this entire angle would be. You know this little bit here was 20, right? Well, no, not exactly. Let me make this a little bit bigger, okay? Originally we had this. We said this was 20. This whole thing was 70.
Yeah.
But we decided that we really went an extra 60. So I want to know what this bearing is.
Okay. Can we build another triangle?
Well, we don't need to yet,
Okay.
because we know that's going to be north something east. What we want to know, what I'm asking you, is this. What is this?
Oh, 90.
No, it's not 90.
Oh, sorry. It's north 90.
Well, 90, you know, when you say north 90 east, that's
80.
really east.
It's 80.
Good. That's why that number between north or south and, you know, the west or the east is always less than 90. If it was north 90 east, that's east. So in this case, we just added, and that's what I was trying to show you here. Let's say we're going 20 degrees east of north, and then we went in that direction another 60. It's just a sum. 20 plus 60 equals 80. Okay. So on this thing, now we've got this north 80 degrees east. Okay. And now let's say we go on our 6 miles. We're headed on our 6 miles. Okay, so you try to do a halfway decent drawing. It's helpful when you have I don't know if polar graph paper would really help anymore, because every time you pivot, you've got like a new center, right? So it probably wouldn't be very helpful. Okay. So let's say the question here is, it's a twofold question, and maybe you know where I'm going to go. I want to know how far away we are from the starting point, and what direction is that from the starting point. So I might write a problem saying, okay, let's say one ship started north 20 degrees of east, went 5 miles, then turned 60 degrees and went 6 miles, and that's where they're staying. I want to head straight out to them as the crow flies, and let's say there's no there's no waves or anything. You don't have to worry about tide. What direction should I go, and how far do I need to go? So that's the sort of question you'll see. Of those two parts of that question, which one looks easier to solve?
Probably the angle.
Okay, the angle.
I mean, the distance traveled between this and
And how are we going to find that?
probably law of cosine.
Okay, probably one of those laws, right? You know, you've got law of sines and you've got law of cosines, and law of cosines is good when we've got like an SAS sort of strategy, side angle side.
Right, but this is just SSA.
This is SSA. Well, how many angles do we really know? We've drawn out this triangle. Can we find this? Well, not yet, because we don't really know this one, right? We don't know this one yet either. Do we know this one?
Yes.
I bet we can find it, right? And let's just actually add up the angles you see. You know this little part is 90. What's this little one inside here?
That would be 20.
Nope, it's the same thing as right here.
Oh, sorry.
It's okay.
So it'd be.
Remember, the direction here is north 80 degrees east.
Okay. Oh, so 8. Oh, so 10 degrees.
10 degrees, very good, very good. You're only 10 degrees away from due east. Okay, so we know this is 90, we know this is 10. Do we know what this one is? This is kind of throwing us back to geometry. Remember alternate interior angles? Does that ring a bell?
Yes.
And they're the same, right? So whatever this one is, so is this one.
Okay, so it'd be 10 plus 20.
10 plus 20, which is 30 plus 90.
Which is 120.
120, very good. So we label that out. All right, so 120 degrees. Do we have enough for law of sines, or do we have enough for law of cosines?
Law of cosine.
Yeah, yeah. If you feel confident using law of cosines, which it sounds like you do, yeah, definitely use it.
Well, I also want to practice it using.
We do. Very good. So let's go ahead and set it up. Now you know that officially there's 3 laws of cosines, but they all kind of have the same thing. Okay. Go ahead and tell me out loud what the law of cosines is we're going to use here.
A squared
Okay.
equals 5 squared
Okay, I see what you're saying. Okay, so 5
plus
squared.
6 squared
Yeah.
minus 2 times 5
Yeah.
times 6
Yeah. Times what?
cos of angle A.
Okay, in this case it's how many degrees?
120.
Do you happen to know without using your calculator what the cosine of 120 is? Going back to trig.
So would that be 1 over 2? Negative 1 over 2?
Yeah, it's a negative, right? Is that okay that it's a negative?
Yeah.
Okay, good job. Yeah, I think it's negative 1/2 as well. Okay, you might be able to do this without your calc. Do you want to?
Not really.
Okay.
Well, let's see, negative 15. 60. So 60 negative 15 plus 15 66.
So what'd you get?
76.
Let me check here. So 5 squared plus 6 squared, 25 plus 36, right? Which is 61. Oh, you're right, because that's a negative, so that becomes a plus. 61. 66? 76?
Yeah, 61.
Let's see. Minus 2 times 5 times 6, that's 10 times 6. 60 cosine of 120. 60
Okay.
times a negative 1/2. So that's 30, and it's a plus 30. So in this case, 91. All right. You know, the thing is, we're trying to do all this work without a calc, which is good to stimulate our mind, but we're going to have to use our calc anyway, because we got to find the square root. I'm not going to ask you to do the square root of 91 without your calc.
So 9.539.
Okay. Yep, I got 91. Okay. So it's probably approximately